All right, guys, we're on day 8 of Unit 7, and in our warm-up, we have triangle QRS with medians, QA, RB, and SC concurrent and centroid P, and they're telling us that PC is x plus 4. All right, and that PS is 4x minus 10. And I put a bracket on this one because I can already tell that this is the bigger piece where x plus 4 is going to fit in there twice. Okay, and so I can now see my equation is that it's going to take 2x plus 4s to equal my 4x minus 10. All right, and that's just one way we can set this up. And so if I distribute, I get a 2x plus 8 equal to a 4x minus 10. If I go ahead and subtract my 2x, I'm left with 8 equaling 2x minus 10, and then add my 10. And I end up with 18 is equal to 2x. Divide by 2, and x comes out to equal 9. However, they asked me to solve for SC. S to C is the length of the whole thing. So what I'm going to do is I'm going to take my 9 plus 4, okay, or my x plus 4, substitute in my 9 to get 9 plus 4, which is 13, 13, 13. And so 3 13s would give me an SC length of 39. Okay. All right, going down, we got a similarity transformation is the composition of rigid motions and or dilations. All right, a similarity transformation does not need to have a dilation since two figures that are congruent are also similar. Okay? Similar figures are figures that look like the same shape, but not necessarily the same size. The similar figures could look like they have been flipped, which is reflected, turned, which is rotated, or slid, which is translated. Okay. A dilation of a scale factor of 1 does not change the size of a figure. Images resulting from similarity transformations are similar because angle measures are preserved and all sides are proportional, okay, which is that fraction equal to a fraction. Okay. Triangles are similar from similarity transformation because angle measures are preserved and triangles are similar based on angle, similarity, or we could be an overachiever and go AAA similarity. Okay. All right, let's take a look down here. Number 1. It says in the diagram to the right, triangle A prime, B prime, C prime is the image of triangle ABC after a transformation. Describe the transformation that was performed. Well, obviously it got bigger, right? The original is smaller, the new one is bigger, and so this has to be a dilation. However, dilation is not precise enough. We have two things that we have to make sure that we are stating. Dilation centered at, okay, with a scale factor of what? Okay, so we have to fill those two things in based on our picture here. So dilation centered at, the typical point of that dilations are centered at is the origin. And we can see if it's the origin if we go ahead and use our spokes. All right, so if we have a straight edge and we can draw our spokes in, what we can do is we can see if our origin and A prime all lie on the same line. And it looks like that they do. Our origin to B and then out to B prime. Okay? And our origin to C and out to C prime. And that's going to ensure that that is our center of dilation. So it's centered at the origin. All right, now we have to go ahead and find our scale factor. So I would say that the easiest way to find our scale factor, okay, is to maybe find the length of one side and then the length of the new side and then divide them. Okay? So if I go and I count, and we could do this on a couple of the sides, easiest one is AB or BC. So I'm going to go AB. So this is 1, 2, 3, 4, 5, 6, 7, 8. And this is 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And so we can take our new side of 20 and divide it by our old side of 8, and 20 divided by 8 is 2.5. Okay. If you're unsure, you could do it with a second pair of sides just to double check it. All right. For instance, the other side that's easy to count is BC. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And so our new side is 15, our old side is 6, and 15 divided by 6 is 2.5. Okay, and so now we are clear that our scale factor is 2.5. All right, if we want to do this in notation, we also could. So it would be a capital D, O for the origin, 2.5 for my scale factor. And that includes all the information we need in order to get full credit on describing our transformation. Now, part B is going to ask, explain why the triangles are similar. So we're going to go ahead and say that dilations preserve angle measure. So all corresponding angles are congruent and triangles are similar by angle similarity. Okay. All right, let's go ahead and take a look at 2. So in number 2, we have a similarity transformation maps triangle RST onto its image, triangle R prime, S prime, T prime, and they want you to identify the composition of transformations. So we are looking at this triangle here being our original, and we want to know what can we do with it to get it to go onto this triangle. And so the first thing you might see is that it's different sizes. And so the first thing you might mention is a dilation. All right, so if we have our dilation and our new side divided by our old side, our new side is 3, our old side was 6, and so that reduces to 1/2 or 0.5. So it's a dilation with scale factor of 1/2 centered at, and hopefully you guys can see that our point R and S are getting shrunken down and closer to T. So it's centered at T. All right, so let me show you what happens. But if I mark half here and half here, this would be my new triangle. Okay, this would be R prime now, and this would be S prime. But you're going to notice to get it onto this triangle, we're going to have to take our triangle and turn it or rotate it. And so our second transformation would be a rotation. And we're rotating around T, so a rotation around T of, and we would have to turn it 180 degrees. And if we take this triangle here and we turn it around T 180 degrees, it would match up. Okay, and so those are our 2 transformations. Now we could also write it as a composition. And so remember that when we write it as a composition and use the open circle, that means following. Our second transformation actually goes first. All right. And so we can go ahead and say that, and I don't think it would matter either if we rotated it first and then shrunk it down with our scale factor of 1/2. I believe the triangles, right? Can you picture it? They would match up. And so it doesn't matter which one actually goes first. All right. But the way we ordered them here, we would put our dilation here, centered at T, scale factor of 1/2. We did that first, or talked about it first. Okay. And then our rotation around T of 180 degrees would go here. And again, these could switch and still be correct in this question. All right. Not always the case in every question with 2 transformations. All right. I'll see you guys on the second side.